Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We're going to continue talking about the repetition structure, specifically about nested loops. And the idea behind nested loops is a loop is inside of another loop. That's basically it. So let's go ahead and type in C#. And we're talking about repetition. Repetition, there we go. And this will be part 7. Specifically, we're going to be talking about nested loops. Okay, and let me open up the toolbox so that I can drag and drop a button, a label. Actually, I'm not even dragging and dropping. I'm just tapping here and then tapping here. I could drag and drop, but it's really the same thing as just simply tapping. And let's go ahead and make all of these 12 points in terms of the size. So I'll select each of these different items, 12 points. And over here, the size will be 12 points. Let me place the label in the upper left-hand corner, and we'll change the text property so that this says rows. And then I'll put a text box right next to it, like this. And I'm going to make this a little bit smaller because the user is going to be entering smaller values for integer values, that is, for rows and columns. So I'll just take these two and then copy and paste. And then I'll place this over here like this. That looks pretty good right there. And I'm going to change that row to columns, the abbreviated form. There we go. And then I'll place a submit button underneath those two. That looks pretty good. In fact, I think that may be a little bit too far away. Yeah, it is. And there, I'll make a little adjustment like that. That looks pretty good. Let's go ahead and take this label, copy and paste it, and I'll go ahead and say auto size false, border style fixed single, and I'm going to move it up like this, and let's see, something like this, kind of big at first. I may have to reduce the size later on. That's fine, I can leave it like that. Now the one thing that I want to talk about is the mono-sized font that I want to use over here. So what I think I'll do is I'll change this to a monospaced, not mono-sized, monospaced font. And I'll just simply select Courier New, which is a very common monospaced font. It just simply means that all of the characters are going to be identical. So that if I type in the letter W or if I type in the letter I, say for example, they both get the same width. So we'll just use a monospaced font for this one. And we'll have it aligned on the top left. That's already aligned to the top left. That's fine. And then I'll simply reduce the size of this. That looks pretty good. Oh, I forgot to change that button. The text property for that button will be submit. And let's get rid of the minimize and the maximize box. And then we'll change that from form 1 to rows and columns. And the idea is based on the user number for the number of rows and the number of columns, they click submit, and it's going to display a row and a number of asterisks or stars based on that user entry. Okay, so let me go ahead and select this guy over here, and let's go ahead and give names to the various items here. And let's say this is going to be txt rows. This guy over here, we'll call that txt columns. For the button, obviously that's going to be btn submit. And then finally we have the label down here, and we'll just simply call that LBL result. Okay, so let me save my work. Let's go ahead and double click on the button, and we're going to start by typing comments such as declarations, get user input, calculation, output. Once again, as I've always stated in my previous lessons, ask yourself, what is it that the user must give to you? What is it that you give to the user? Clearly, the user is going to have to give you a row and a column value, and then you're going to have to give some sort of an output state, an output string, so you can display the rows and the columns of asterisks. So over here, we'll say int rows I should say, int columns, and then string output. And we'll assign that to nothing at first so that it's blank, and then later on we're going to populate that. Okay, another thing that I want to introduce in this video lesson is the usage of the try block. Just type in the word try, and then it says over here, tab twice to insert the try snippet. So tab, tab. Okay, so this is the try snippet. Now, what the try block does is it tries to do something. What is it that we are going to try? We are going to try to convert into a 32-bit number, 32-bit integer, whatever is inside of txt rows.txt. We're going to do the same thing for columns. We're going to try to convert to int32 whatever is inside of txt columns.txt. And we've done this before, and I'm kind of using a different language. I'm saying, hey, we're going to try to do this. Well, of course, we've converted before. In past video lessons, we've converted numbers into integers and placed them into integers. Here's the deal. What if the user accidentally types in something erroneous, like, say, for example, a letter or a character? Well, you can't take a letter or a character and convert it into a 32-bit integer to place it into an integer. So we're going to try to do this, but if this attempt was not successful, let's go ahead and display a message box to the user so that they have a better user experience in terms of what they did wrong, and then we can correct it. So it probably has this word throw. Get rid of that for right now. We'll talk about that later. And I'll just hit delete, and then I'll hit tab a couple of times. If you tried to do this and it didn't work, let's catch the exception, the error, the problem that existed as a result of trying to take a letter and converting it into a number. Let's catch that and deal with it in the following way. Message box dot show, and let's go ahead and type in what the message is. Well, first of all, you need to enter a whole number. If you didn't, oh, by the way, let's assume, but because you didn't enter a whole number, let's enter the caption, which is invalid input. This is the title on the top of the message box. So we'll say invalid input. Now, I'm going to type in, oh, actually it says message box right here. Just double click here, dot. I want an OK button, and then comma, and then let me just type in message. All I have to do is just type in a couple of them. Message box icon, that's the one that I want, dot, and in this case, let's say I'll have the error, so I'll double click. So if the user entered anything else other than numbers, because only numbers can be converted, right? The numbers that were entered into a text box, that is, which are treated as text, we can convert those into numbers and place them into, or assign them, that is, into integers. But if I enter the letter Q or hashtag or something else, this is not going to work. So what we'll do is we'll make it so that we can display a message box indicating that the user entered something inappropriately. And then let's clear out all of these items. Like, let's clear out the label. Let's clear out the text boxes. So we'll say like this. Let's clear out the rows. And then finally, we're going to type in return. Let me explain what this does. First of all, if the user really did enter appropriate values, like 2 and 3, say for example, then we go from try out and we skip over catch. Only when the user enters something inappropriate, like a letter or a symbol, say for example, will we catch that erroneous input. We will display a text box. We will clear out the label and the text boxes. And then we want to jump out of the program. We don't want to calculate. We don't want to output. We just jump out. That's what the context of the usage of this word return does. Later on, when we talk about functions, we're going to talk about returning values that a function actually performs, a calculation that's performed within a function. That's not what this is. What this is doing is it's basically saying, hey, don't continue. Jump out of this particular procedure, which of course is the click event for this button. So we're going to jump out of that and not even execute calculation or output. So this is a great way, a try block is a great mechanism to use to make sure that the user is entering valid values. It makes your program more robust. Instead of crashing your program because the user entered something inappropriately, now we have a way to recover and just say, hey, I'm going to try to do this, and if you made a mistake, I'm going to catch it. Here's my message to you to let you know what you did wrong. And by the way, all those erroneous things that are in the text box or the label, perhaps, I'm going to get rid of them, and then I'm going to jump out of this procedure to allow you to enter in correct values. And if you do enter correct values, then I can try this one more time. If you did, in fact, enter two valid numbers, then I won't even do the catch, because the catch is only if you did something wrong. If you did something right, we jump out of here and we perform our calculation. All right, well, what are we going to do in our calculation? All I want to do is to display however many rows and columns of stars based on the user input. So what we're going to do is we're going to use a nested looping statement. What I'll do is, by the way, did you notice that I did not create a counter over here? Let me show you how to dynamically create a counter using the for statement. So what I'll do is I'll say int I and a semicolon as long as I is less than the number of rows, and then I plus plus, open and close curly braces. What this does is it says I want you to declare a variable I. Now I'm using this variable I as a counter. I could have typed in counter, I could have typed in row counter, column counter, whatever you want to type. I'm just using that single letter right there. Very common for computer scientists to do stuff like this. We'll just use a single letter that's being treated as a counter. Could I have gone up here and said int I and then semicolon? Sure, I could have. I could have declared a variable up here to use it as a counter. I'm doing the same thing here. I'm creating this just for the existence of this for statement. Once I jump out of this for statement, there is no definition of I. I only exist in this for looping structure. It is a temporary counter. As long as that counter is less than rows, then we're going to keep on looping, and for every iteration, I is going to be incremented by 1. Well, I'm going to do the same thing for all of the columns. So we'll say for, and once again, I'll just go ahead and declare a variable j, and as long as that variable j is less than the number of columns that the user wants, and then j++ means that we are going to increment them one by one. We call this a nested looping structure. This looping structure is inside of this outer looping structure. So, it's kind of like my son who likes to build slot car tracks, and he likes to race with me. So there'll be a track that goes like this, right? It's this outer track, and then we have this little inner track that we go through, and then we go back to the outer track, and then we have a little inner track, and then we go back to the outer track. That's what this is like. So we have an outer track, and then an inner track, an outer track, and an inner track, so forth and so on. Well, inside of this inner nested looping structure, I'm going to say the output is going to be the old output, and we're just simply going to concatenate a star. So this is going to concatenate stars for however many columns that the user wants. Once I've done that, let me get out of this for statement, and I need to go to the beginning of the next line, right? Because basically what I'm doing is I'm drawing row by row of all the stars. So I'll just simply say environment dot new line to go to the beginning of the next line. So if I were to let me just create a comment over here, and I'm going to erase this in just a moment. I'm just trying to illustrate to you what it's going to look like. So let's get rid of that. And let's see here. So it's going to look something like this. Let's say, for example, that I draw a bunch of stars, like 1, 2, 3, 4, 5. Go to the beginning of the next row, 1, 2, 3, 4, 5. Go to the beginning of the next row, 1, 2, 3, 4, 5. So this would be an example of 3 rows and 1, 2, 3, 4, 5 columns. So I'm going to draw the first row and then go to the beginning of the next line. Draw the next row, go to the beginning of the next line. That's the strategy that we will use for our nested loop. And then, of course, when we're done, we're just simply going to say LBL result. That is going to be assigned whatever the variable output contains. Let me run this program, and then we'll do a little bit more deeper analysis to see what's actually happening here. So let me save my work. I'll click Start. And let me say 3 rows and 4 columns. What does that look like? So 3 rows, 1, 2, 3, 4 columns. Looks pretty good. How about 6 rows and 6 columns, say, for example. Okay, 1, 2, 3, 4, 5, 6 rows and 1, 2, 3, 4, 5, 6 columns. Yep, looks good. Can I bump this up to 10 columns? Sure, I can. However many rows and however many columns that you want. And of course, we want that to fit inside of our label. So let me stop the program. And let me just stop the program at this point so you can see what's happening programmatically. We're going to freeze time here. So I'm going to place a break here. Let's go ahead and run the program. The user will, well, let's say that we have 2 by 3, say for example, 2 rows and 3 columns. All right. At this point, I does not exist prior to this for statement, but we are now going to use this as a counter. We are going to set I to 0. As long as 0 is less than rows, then we are going to execute this. So over here, I'm going to step over and notice what happens. This is a true statement. So guess what? There's a for statement inside of the for statement. Here, I'm going to declare J, and I'm going to set it equal to 0. Hey, is J less than the columns? Yeah, 0 is less than 3. That's a true statement, so I'm going to go ahead and step over, which means that we are now going to execute this inner looping statement, which is simply taking output, and it's going to append it. Right now, as you can see, output is nothing. We are about to append a star to it. So here it is. There's the star. Now I'm going to go back over here and ask, well, actually, before I ask, I have to increment J. J currently is 0. We're about to increment that by 1. So now J is 1. Now I'm going to ask, is J less than the number of columns? Yes, 1 is less than 3. So guess what we do? We execute this again. Then we go back over here, increment J, and ask, hey, is J still less than 3? Yep, it is. So we execute this again. And then we increment J. J now goes to 3. Is 3 less than 3? No, it's not. So we jump out of that for loop. We now add a new line to whatever the output is. So here's what the output is. We add a new line. In other words, go to the beginning of the next line. And so that's what this means. Go to the next line, go to the beginning of the next line. And so then we go to the outer loop. I was 0. Now it's going to be 1. So then we ask the question, is 1 less than 2? Is 1 less than 2? Yes, it is. So we go into the for statement. Guess what happens to J? J gets reassigned. It was 3, but guess what happens to J? Now J gets reassigned back to 0. Then we ask the question, is J less than the number of columns, which is 3? Yes, it is. So we do this all over again. And that's how this inner for statement works. We are basically going to loop this however many times like this. Watch this. Outer, inner loop, go back to the outer, do the inner loop, go back to the outer, inner loop. And every time we do the inner loop, notice that J gets reset. It's like you and I are going to the racetrack and we're starting with our clickers in our hands. We're going to set those to 0 every time we encounter this for loop. We reset it to 0. We execute it a certain number of times, go back out, get ready to reset your counter because it's a brand new race. We do that over and over again, just like that. Okay. Then we are going to keep on doing this as long as this outer loop is true. As long as it's true, we keep on looping. Let me go ahead and click continue. Finally, when it's all done, we're going to display the output to the text variable or to the text property of this label, and we get something like this. So this is a great video lesson to introduce a couple of things. Number one, you have nested looping structures. In this case, I used for. I could have used while. I could have used do. In this case, for is nice and concise. I love using the for looping structure because it's so concise. You have the beginning, you have what the criteria is, and how you're going to iterate by 1, by 2, by 3. In this case, we're adding 1 to our counter. And then over here at the very top, this was a gentle introduction to the try block. The try block is great. In fact, I never tested that. Let's try this one more time. Let's say that I enter 1, which is correct, but I enter the letter Q. So watch what happens. Okay, invalid input. Isn't that what I said over here? Sure. Invalid input is the caption. Enter a whole number. That's the message. I'm going to display an OK button. There it is. And I'm going to display an error icon, which is right here. Perfect. Notice that I have items here, here. And so when I click OK, they are gone. Now, let me go ahead and display something appropriate, like the number 4, the number 5. That works out. Then I decide, okay, I'm going to do this again, but I enter accidentally the letter W, say for example. Okay, once again, it's going to pick that up because what am I trying to do? I am trying, move this over here, I am trying to take that letter W, convert it into a 32-bit integer. You can't. You can only take a number that is placed in this text box or this text box and convert that into a 32-bit integer. If you can convert a number into a 32-bit integer, perfect. The try block works. You jump out over here. But if this is not a number, if this is a letter, or if this is a character, then what ends up happening is we can't do this. You go to the catch section. You catch all these weird exceptions, such as entering letters and characters. Yep, I caught it. Can't do that. I'm going to display a message box for you. I'm going to clear out the label in the text boxes, and then I'm going to jump out of the program. I am not going to continue with the rest of this stuff over here, the for statement and this. No, when it goes to return, it jumps out and it gets out of this particular procedure, which is activated when you click this button. So again, a very beautiful and an elegant way of making your programs robust. This is a wonderful user experience when something bad happens like this. How about this? I'm not going to enter anything. Why did this come up? Well, you're trying to take a blank, right? Here's blank. Here's blank. You're trying to take a blank and convert it into a number. You can't do that. So I got to display a message box for you. And so in this case, the user feels like, oh, this is no big deal. I see what I did wrong. I have to enter a whole number. That's why this is an invalid input. I click OK, and I get a chance to do exactly that, what I'm supposed to do, which is enter integers, and then I can go from here and have a wonderful user experience. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.